This video is part 3 of the Kinematics chapter. It includes motion problems and Galileo's law of odd numbers. So starting with the first problem, a ball is thrown vertically upwards from the top of a tower with a speed of 100 meters per second. It strikes a pond near the base of the tower after 25 seconds. The height of the tower is. So first, I like to start with drawing a picture just to visualize the problem. So there's a tower, let's say the height is h. A ball is thrown vertically upwards with a speed of 100 meters per second. And it lands at a pond after 25 seconds. So that's the information we've been given. And I think this is just a formula-based question, so we can apply the formula S equals ut plus half at squared. This is an equation of motion. And S is just h, that's the height. U is 100 meters per second, that's the initial velocity. T is 25, since that's the time taken, plus 1/2. Acceleration is going to be -10 because since it's moving downward, gravity is acting on it, and gravity is about 9.98, so we'll round it up to 10, minus 10, t squared, which is 25 squared. So after simplifying this, we're going to get height is equal to 2,500 minus 3,125, and the height is minus 625, but obviously height can't be negative, so it's just 625 meters. So the height is found to be 625 meters. So this was the first problem. Then I'm gonna quickly derive the time of flight. The time of flight is just the time that the object is in the air or is in flight. For example, for the last problem, the time of flight was 25 seconds. So time of flight is derived from the formula S equals ut plus half at squared, since it involves distance and time. So let's say there was a tower and a ball was falling from it with an initial velocity of u, and the tower was height h. So to figure out the time of flight, we just plug in the information into the equation. So the height is going to be minus h, since it's moving downwards, we'll take height to be negative, equals, there's no initial velocity, so we're going to cross that out to be 0, minus half gt squared, and it's minus because the gravity, since it's moving downwards, gravity is going to be negative. So from here, t is going to be equal to root 2h by g, and that is the time of flight. Time of flight is square root of 2h by g. And this is important because it can help you quickly solve problems. So this is a time of flight problem. A boy standing at the top of a tower of 20 meters height drops a stone. Assuming g equals 10 meters per second squared, the velocity in time when it hits the ground is. So again, this one, we just implement the time of flight formula. T is equals to root 2h by g. And the height is 20 meters. Gravity can be taken as 10. So this is going to be equal to root 4, which is equal to 2 seconds. So time of flight is 2 seconds. And then the other part of the problem is the velocity. You have to figure out the velocity. So we can use v equals u plus at. So in this case, v equals u is 0, since the initial velocity is 0, plus or minus 10, because since it's moving downward, we're going to take gravity to be negative, and time of flight is 2, since it takes 2 seconds, as we just figured out. So v equals minus 20 meters per second. That is the velocity, final velocity. So that was one problem which uses time of flight. And the next one is the velocity of a train increases uniformly from 20 kilometers per hour to 60 kilometers per hour in 4 hours. The distance traveled by the train during this period is. So for this problem, we're given the time, which is 4 hours. We're given the initial velocity, which is 20 kilometers per hour, and we're given the final velocity, which is 60 kilometers per hour. So, and we're asked to find the distance. So for this one, there isn't an exact equation of motion that we can use, but there's another formula, which is S equals U plus V, the total velocity, final velocity plus initial velocity, times time divided by 2. This is another formula that you can use. And so S equals 20 plus 60 over 2. We just plug in the numbers at this point, and we simplify to get S equals 160 kilometers. So this is just another formula to keep in mind. And in this case, displacement is 160 kilometers. Now, a new concept, Galileo's law of odd numbers. This is a very important law. So the law basically states that the distance covered by a falling object in equal time intervals is linearly proportional to odd numbers. So what this basically means is that when an object is falling in equal time intervals, for example, let's say 1 second, 2 second, 3 second, 4 second. So the first second, the distance covered will be x. The next second, the distance covered will be 3x. The next second, the distance covered will be 5x, and the fourth second, the distance will be 7x. But for this to work, the time has to be linear. Time intervals have to be the time intervals have to be linear. So for example, it could be in the first 2 seconds, it falls x meters, and the next 2 seconds, it falls 3x. The next 2 seconds, it falls 5x, and the next 2 seconds, it falls 7x. So this is the law of odd numbers. It's pretty straightforward, and it's really helpful. So an equation or a problem, including this law, a stone falls freely under gravity. It covers a distance h1, h2, and h3 in the first 5 seconds, the next 5 seconds, and the next 5 seconds, respectively. The ratio between h1, h2, and h3 is. So we're given that it's linear. Every 5 seconds, the distance is h1 for the first 5 seconds, h2 for the next 5 seconds, and h3 for the final 5 seconds. So since this is linear, the first h1 is going to be x, h2 is going to be 3x according to Galileo's law, and h3 is going to be 5x. And it's asking us to find the ratio of h1, h2, and h3. So that's going to be x is to 3x is to 5x. And this can be simplified as 1 is to 3 is to 5. So that would be the ratio. So this is a pretty straightforward law, and it can be very helpful. Okay, so last problem, or a body starts from rest and moves with constant acceleration. What is the ratio of the distance traveled by the body during the fourth and third second? So again, another Galileo's law of odd number problem. So the fourth second, it's going to be the first second, second second, third, fourth. So the first second is going to be x distance traveled. The next second is going to be 3x. Next is going to be 5x, 7x, and then 9x. So during the fourth second, the fourth second is 7x and is 2, the ratio. And third second is 5x. And this can be simplified as 7 is to 5. So the ratio of the fourth to third second is 7/5. And then that was the last problem. So that's it for this video.